Picking up where we left off yesterday in lesson 6.5. Okay, we were getting ready to graph. I did just change up as we talked about that my labeling is basically 1/10 for every ring. I just labeled every other ring because doing this on the BenQ, I can't write that small. I don't know if you guys can write that small, label every ring, but I would be perfectly fine with every other ring. That is still indicating your scaling there. Now, I'm going to change colors and find a different color to graph in. So, as we do this, just like regular graphing, we're putting our dots. Now, you do want to pay attention to the order we graph these dots, because the order you graph the dots is the order you're going to connect the dots with. Does that make sense? Now, I'll be honest. On something like this one, it's going to be fairly obvious. I'm not sure if we have any of the... We might, but just pay attention to the order you draw the dots. That's the order you connect the dots, okay? So, 0, 0 is 0, 0. There's your pole, okay? Or, I guess we want to think r theta, so. Okay, 1/2 pi over 6. So what are we doing? On pi over 6, we go out to 0.5. Okay, square root of 2 over 2, comma pi over 4. So on pi over 4, we're going to go out to 0.7-ish. Mine's just going to look like 0.7. I mean, it's 0.707.
It's
so.
a real big difference.
Okay. Square root of 3 over 2, comma pi over 3. So on pi over 3, we're going out to almost 0.9. Not quite 0.9, something like that. Pi over 2, 1. So where is my 1? It is where your very next ring would be. Okay, and I only did this because the farthest I'm going to go is to that very next ring. Now, if you left yours as every ring is 2/10, you obviously have to adjust what you're doing from what I'm doing.
Because I'm getting confused.
Okay, and that's where you just need to graph on your own. Okay. Now, 2 pi over 3, square root of 3 over 2. What's happening? On 2 pi over 3, we're going out to almost 0.9. Okay. On 3 pi over 4, we're going out to 0.7-ish because it's 0.707. Wait a minute. Back it up. I goofed, didn't I?
I don't know.
They should be the other.
No, it's the right way.
This is what the graph's supposed to look like. My goof was that I didn't go out to the almost 9th ring. I, just miscounted. I'm forgetting the last ring is the 9th ring, right? 0.9 is our 9th ring. So now on 3 pi over 4, I should be about 7. There we go. Where am I at? 5 pi over 6, 1/2. So 0.5. At pi, we're at 0. So what's that mean? We're overlapping that center dot we already did, yes? Okay. Now what? 7 pi over 6 and negative 1/2. What's that mean? Here's 7 pi over 6. Negative 1/2 is going to take me backwards through the pole onto pi over 6. Don't we already have a dot there?
Overlap.
Okay, so in this case, it happens to overlap. That's not something that's always going to happen, but it does happen sometimes. 5 pi over 4, negative square root of 2 over 2. 5 pi over 4, negative 0.7 takes us to this point on pi over 4 I already have. 4 pi over 3 and negative 0.8, or 0.866. Well, right there. That's the dot I already have here. 3 pi over 2 and negative 1. Here's 3 pi over 2. Negative 1 is the dot we already have. Are you noticing a trend here?
It's a pattern, yeah.
Okay. Does it continue in the fourth quadrant the same way? 5 pi over 3 goes negative 0.866. 7 pi over 4 is negative 0.7. 11 pi over 6 is negative 0.5. And 2 pi is at 0 there. Okay. When I connect these dots, what have I essentially drawn? A circle. Okay. So don't think of this as a rigid formation like straight lines connecting these. Think of more of a curved formation, and so essentially a circle. There you go. Fine. Like a hot air balloon, is that what you're seeing? Whatever you want to visualize it as. So. Okay, guys. Questions? Got the gist, yes?
Yep.
Okay. Shall we try the next one?
No.
Okay. Our next equation changes up. It's 2 cosine theta, yes? So, what are we doing? Cosine of 0 times 2.
0. I'd say we need to get our calculators out.
Heh. That's funny.
Oh. I mean,
Oh,
we'd
shoot,
already
it's
have
What's a
one.
cosine graph look like?
Yeah. I remembered from yesterday.
I didn't.
Or you can go back to your quadrants, yes, your ordered pairs. But here's the deal, guys. I personally visualize a cosine graph. Where is cosine at 0? It is up here at 1. What is 2 times 1?
2.
2. Okay? If we go ahead and put these pieces in, it crosses through at pi over 2. Its minimum is at pi. It crosses back through at 3 pi over 2, and it maxes at 2 pi, yes? Okay, or again, go back to your ordered pairs, yes? Okay. 2 cosine pi over 6. So what is cosine of pi over 6?
Square root of 3 over 2.
Square root of 3 over 2 times 2?
Square root of 3.
Square root of 3. Do you guys remember from yesterday what square root of 3 is?
No.
It's in between 1 and 2. I don't know.
1.7 something?
Do you want more than
So, sure.
I have 1.732, but here's the deal, guys. We're going to be graphing this on a graph. All right, how specific can you get?
not very?
I mean, 1.7 gets you plenty specific enough. Okay, what about pi over 4? Cosine of pi over 4. Square root of 2 over 2 times 2. Square root of 2. What is the square root of 2 as a decimal?
Like 1.4?
1.414 is what I know it as.
Sure.
Pi over 3.
1. Well, yeah, 1.
The cosine of pi over 3 is 1/2. 2 times 1/2 is 1. Okay? What about pi over 2?
0.
Cosine of pi over 2 is 0 times 2 is still 0. Okay? 2 pi over 3.
Negative square root of 3.
Nope.
What?
Ooh.
We forgot to. I did.
I can agree with negative.
Alrighty then.
Why do we know it's negative?
Because in the sign plus it's in sign.
All students take calculus, so we know next 3 are going to be negative. Negative what? Nope.
Negative.
Well, we could talk negative 1/2. and then multiply by
Be -1.
2.
That's what I just said.
So
Oh.
I was just kidding.
-1. You were just doing the cosine. Is that what you're saying?
Yeah.
Okay, that works.
Oh.
It's because I have that 9.
Now,
Yeah.
what did you guys do when you gave me the square root of 3 thing?
We were looking at the wrong order.
You guys were going the 6th. Remember, we're how far from the x-axis, right? So we went up and over, and then when we go head back down to the x-axis, you're reversing that order, aren't you?
Can we get the 5 pi over
Pair
6?
up.
Oh, no.
The fact that 2 pi over 3 is going to match with pi over 3. What's 3 pi over 4 going to match with?
Square root 2.
Pi over 4, so negative square root of 2. What's 5 pi over 6 going to match with?
Negative square root of 3.
Negative square root of 3.
No.
Okay.
Pi is -1.
Now, what about pi? Cosine of pi is -1 times, 2 makes it -2. Okay. What about this next quadrant?
Wait, it's possible.
Okay.
It's all negative again.
It's negative. Negative square root of 3.
We're going to be in a tangent quadrant,
So then now it's
so it's going to be negative. This is a over 6 angle, so it's going to be negative square root of 3. What about 5 pi over 4? Negative square root of 2. What about 4 pi over 3? -1.
And then 0.
3 pi over 2?
0.
Cosine of 3 pi over 2 is 0 times 2 is still 0.
Yay.
What about the next quadrant?
It's possible.
Now we're in quadrant 4, so we're positive angles. What about the 5 pi over 3?
1.
It's going to match up with the pi over 3 angles, right? So we're positive 1. 7 pi over 4? Square root of 2. 11 pi over 6? Square root of 3. 2 pi?
1. 2.
2.
2.
Cosine of 2 pi is 1 times 2 is 2. Okay? There's going to be patterns when you're just multiplying by something. Adding, subtracting, different story. But, okay. As we go to graph this, you need some angles on here. Pi over 6, pi over 4, pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6. I guess you guys are going to be mad that I didn't do pi over 2.
Yeah.
Mm-hmm.
Furious.
We've got pi.
It's ready to get back.
Let's see.
But right.
7 pi over 6, 5 pi over 4, 4 pi over 3. I hit the spot that I can't write.
We believe you.
3 pi over 2,
5 pi over 3.
5 pi over 3.
From the chairs.
7 pi over 4. Wait a minute, I'm off here. Okay, no, I'm just at a weird angle. What do we need? 11 pi over 6. And this is 0 or 2 pi, right?
Yes.
I'm not going to label it because if I put my countings out there. Now, we have to be able to go up to 2, yes?
Yeah.
So we can't label by 0.1s like last time.
We'll put 1 in the middle.
The middle is 0, my dear. You don't have that option.
Like in the middle of the.
In the middle of the 9.
Like at the
In the
fifth.
middle of the 9.
Yeah.
Her bus is a little bit shorter.
Okay, so in other words, basically counting out to 2 where my invisible 10th ring is going to be 2. Is that what you're saying? So that means what does each line represent?
2
2/10.
I didn't get that far.
Well, you've got to be able to get that far, or it's not going to work. Okay? So first line is 0.2. Second line is 0.4. Third line is 0.6. Next line is 0.8. This will be 1, 1.2, 1.4, 1.6, 1.8, and then 2 is going to be that next line, okay? What?
Write that small.
I know. Again, can you label every other line? I'm perfectly fine with that because you are indicating you're labeling, okay? You don't have to label every line. I tried it, it didn't go well. Okay, shall we see what this one looks like?
I mean, we got nothing better to do.
Yeah. I think some of the more interesting ones are in the homework, so. Okay, 0, 2. Where's 0, 2?
Oh, way out here.
On your 0 degrees, you're going out to 2. So that's your 10th ring if you're doing it my way. Pi over 6, 1.7.
Kind of in the middle of 1.6.
So in the middle of your 8th and 9th rings. Pi over 4 and 1.4.
Same thing as being in the middle.
Actually, 1.4, it's 1.414, but it's going to be more on a ring if you ask me. It's going to be on your 7th ring.
That's what I was thinking.
Pi over 3 and 1. That's on your 5th ring. Pi over 2 and 0. That's at the center. 2 pi over 3 and negative 1. So here's 2 pi over 3. Where's negative 1?
Way down yonder.
Backwards through the circle. And it's 5 circles out. Or 5 rings out. 3 pi over 4 and negative 1.4. So backwards through the circle, negative 1.4 is the 7th ring out. 5 pi over 6 and negative 1.7. Oh, crud.
Oh, man.
Sorry, I was on the wrong line. Okay, sorry, I had to redo my 1.4. Now, my 1.7 on 5.6, it's going to be negative, so we're going backwards through the circle in between your 8th and 9th circles. Four pi over 3. Nope, I just skipped. Where am I supposed to be? Pi and negative 2, yes? Here's pi. Where's negative 2?
It overlaps.
A dot we already have, yes? Okay. 7 pi over 6, negative 1.7. Already have it. 5 pi over 4, negative 1.4. Got it. 4 pi over 3, negative 1. Got it. 3 pi over 2 and 0.
Already got it.
Got it. 5 pi over 3 and 1. 7 pi over 4 and 1.4. 11 pi over 6 and 1.7. 2 pi and 2. So essentially, again, we did
Overlap.
another circle.
This one can't be 100.
Really bad.
-2.
Oh,
This one looks like a water.
Mine's crooked.
Now, I'm pushing you guys to try and think about how to fill these in without just going to the calculator. Obviously, your calculator is your backup and your check, yes? Okay. I'm pushing you guys because this is good practice of how to do our trig values. Now, your calculator, as long as you get in the right mode, would allow you to check this, right? So if you start second guessing yourself, please, by all means, use this calculator. And some of them may be more complicated than what we want to do in a calculator. Or did you try to graph it? So you're going to have to zoom in, it looks like. I mean, keep in mind, we only went out to 2 on this one. I don't know which one you graphed there. But that's another thing. Can you graph these on the calculator and double check them? Definitely. You're going to have to be in polar mode and radians because we're using trig functions. Okay?
I thought it was.
Now, if you do, try z square on that, one of your zoom options, and it might make it look more circle-ish. Yeah. Okay. Keep in mind, guys, the graphs on your calculators are rectangles, right? But they're labeled, they're 10 by 10. So one of those 10s is more stretched or more compressed than the other, whichever way you want to think about it. So when you get something, it's not going to necessarily look like it was looking like an oval, although we drew circles, didn't we? Or we attempted to draw circles. Okay, so if you go to the z-square option, once you get it zoomed in, that makes it so that your screen is more equivalent. Like one direction may go to 10, the other direction doesn't go as far. So. Okay, let's try another one.
It's not a bit.
This one's not going to be a circle.
Oh man, why not?
We get to change it up.
I was getting used to these circles.
Okay. R equals secant theta. What are your thoughts about secant theta?
Let's skip it and speed up.
Not the thoughts I'm looking
That's not a
for.
very good thought.
We won't talk about whether he's agreeing with her or not. Just
Mentally, I'm agreeing, but I know we got to get it done so we can do the homework. Move on.
That's enough.
okay. What do we know about secant?
Mario.
1 over.
Okay, it is the reciprocal of cosine. Yes.
Yes.
So
Oh, 1 over cosine.
I didn't even catch that he said the wrong thing. So
I said sine.
okay, it is the reciprocal of cosine. So this is 1 over cosine. I'm going to push us to think about the chart again, just because it's just a trig function, okay?
It's kind of fun.
If you get fancier, again, you can use the calculator, but now, secant of 0. 0.
No, it's
1 over
1 over 0.
cosine of 0.
1 over 2.
Cosine of 0. Cosine of 0 is
Oh,
1.
I was doing the other chart.
What's the reciprocal of 1? 1.
Oh. I thought it was 2.
But last time, what was our function last time?
Oh, times
2 cosine theta.
Goodness
Our function this time is just 1 divided by cosine theta.
That's good.
Dang it.
So obviously I need to, there's my cosine again, yes?
Yes.
It's a struggle, guys. The struggle is here.
It's Thursday. Wait, one more.
Who asked?
I'm just trying to have a positive outlook. So, show.
Okay, guys. Now, what about secant of pi over 6? Would be my brain says it's the reciprocal of cosine of pi over 6. So if cosine of pi over 6 is square root of 3 over 2, then it's 2 over square root of 3. Now, if we have it on this chart as 2 square root of 3 over 3. Any way we go about that, we're going to have a decimal here in a bit, aren't we? So whether you call this 2 over square root of 3, whether you call it 2 square root of 3 over 3. Anyone got the decimal for me yet? Because we're going to have to know these decimal values, right?
1.1547. 1.156.
1.2.
I agree with 1.2. I wrote down a little bit more just so we have it. So. I agree. I'm not going to disagree there. Okay, guys. What about pi over 4? Secant of pi over 4. My brain, if I'm not staring at that chart, says the reciprocal of cosine of pi over 4. Because I know the cosine of pi over 4 is square root of 2 over 2, right? But square root of 2 over 2 comes from, if you look at our previous form, 1 over square root of 2. The reciprocal of 1 over square root of 2 is square root of 2. What is square root of 2 as a decimal? 1.414. Okay, what about pi over 3?
Ooh.
The reciprocal of 1/2 is 2.
Wow, that was easy.
Okay. 3. Pi over 2.
Negatives. Oh wait, not with that one.
No, 0.
0.
So.
What is secant of pi over 2?
1 over 0, but is that just still 0?
Oh, 0.
Undefined.
1 over 0 is error.
Not there.
Undefined.
It's a black hole.
Because it would be 1 over 0,
Non-existent.
and we don't have 1 over 0.
So you
Okay.
just scratch that point altogether when you go to graph that?
Pretty much.
You can't.
I mean, you can try and grab that line.
Okay. What about 2 pi over 3, guys?
Negative.
We're in quadrant 2 now.
Negative.
Quadrant 2, when we talk about secant and cosine, are negatives. So they are negatives.
Negative 2.
Negative 2.
Negative square root of 2.
Or how do you feel if I say negative 1.414?
I wouldn't be mad if we did that.
And 5 pi over 6?
1.155.
Is it 1.155?
Yeah.
I thought you said 6 earlier, which is why I wrote 6 here.
No. I meant 5. But I very easily could have said 6.
Okay.
It matters.
Exactly. At that point, it's not going to matter, but okay. Pi. And what's the reciprocal of negative 1?
Negative 1.
Negative 1. Okay. What about the next quadrant?
Or will still be negative.
They'll all still be negatives because we're talking about secant, which is talking about cosine, but we're in the tangent quadrant. So we got 3 more negatives. And 7 pi over 6 is going to be the negative 1.2 that some of you are putting, right? Negative 1.155. 5 pi over 4. Negative 1.414. And 4 pi over 3. There's the negative 2. What about 3 pi over 2? Cosine of 3 pi over 2 is 0, so secant of 3 pi over 2 is undefined. What about the next 3?
Positive.
Okay, we're in positive because we're going to be in quadrant 4. What about 5 pi over 3? 2. 7 pi over 4? 11 pi over 6?
1.155.
And 2 pi.
1.
Reciprocal of 1 is 1.
Yay.
On our homework, will you give us? Didn't you already give us the graphing?
No, I haven't. We'll talk about it later. Okay, guys. On this,
Oops.
we probably need to label. I should have scooted this one up, but I forgot. But okay. Probably need to label these. So pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6,
5 pi over 4.
5 pi over 4, 4 pi over 3, 3 pi over 2. We're doing thirds, so 5 pi over 3, 7 pi over 4, 11 pi over 6, and that's 0 and 2 pi. How should we count? I think I'm gonna. That work? I think that works. Are we wanting to go out to 2 again? Kind of like what we did last time. So the first one is 0.2, 0.4, 0.6, 0.8. That's going to be 1, 1.2, 1.4, 1.6, 1.8. The invisible ring is 2. Okay. Ready? 0, 1. On 0, you go out to 1. Pi over 6 and 1.2. So on pi over 6, we go out to 1.2. Is this going to work? Pi over 4 and 1.4. Technically it's 1.414, but close enough, right? Oh, I guess that wasn't quite 1.2, was it? That's why that point is not making me happy. And here's the difference between you and I right now. I know what this graph is going to look like. So, yeah, it's not quite all the way to 1.2, which does make a difference technically. Okay, where are we at? Pi over 3 and 2. Pi over 2 is undefined, so we have no point there. 2 pi over 3 and negative 2.
Never mind.
No, we didn't.
Just kidding.
Ooh, man, I'm going to have a problem here. Okay, well, okay, 2 pi over 3 and negative 2 is supposed to be, it's not going to let me draw it, but it's supposed to be right there, yes? Because 2 pi over 3, negative 2 shoots me back through the center, and I'm going to be down here at negative 2 on 5 pi over 3, yes? Okay. What else do we have? 3 pi over 4. Negative 1.4 is going to shoot me back through the center. Should end up about there on 7 pi over 4. 5 pi over 6. But it's negative 1.155. So I'm going to shoot back through here. And I'm going to be just before 1.2, correct? I've lost track of where I'm at. Pi and negative 1. Here's pi, negative 1 shoots me back through there. Are we starting our overlaps?
Yeah.
Yeah. And you won't, I can't guarantee you'll always have those. Depends on what we're doing. But if you continue going on, are we at overlap time?
Mm-hmm.
Let's see. 7 pi over 6 and negative 1.155. We've got that. 5.4 and negative 1.4. 4.3 or 4 pi over 3 and negative 2. Undefined. 5 pi over 3 and 2 is my one dot that I couldn't write. And all these other dots are good. What do we draw?
A line.
A straight line, yes. That is a straight line. Give or take, right?
Mine's
Close enough.
straight enough. That's pretty straight. No.
Okay. Now, one more. Do I have time? I don't know. I say we cheat off of ourselves. Off of ourselves.
Oh, wow.
Bad.
Okay, what do I need to cheat off yourselves?
Is that just learning from yourself?
It's copying down some of your previous answers. So,
Me first.
what are we doing? 1 plus sine pi, or 1 plus sine of theta. What graph have we already done that would be helpful here?
Design.
Sine. So if we do 1 plus sine, can we take those answers and just add 1?
First though.
Okay. Now, that's what's going to be my suggestion, because I don't really want to say like, okay, so the first one At 0, it was 0. So what's 1 plus 0? 1. At pi over 6, okay, that was 1/2. You could say 1.5.
1.5.
You could say 3/2, but it's going to be easiest to just say 1.5. At pi over 4, it was square root of 2 over 2. Well, I don't really want to say 1 plus square root of 2 over 2, but it was 0.707. So if you add 1 to that, 1.707. And then pi over 3 was square root of 3. If we add 1 to it, 1.866. Pi over 2 was 1, so 1 plus 1 is going to be 2. Now, we have to think carefully here. And we're still okay with it. We're still adding positive numbers here, right? Because in quadrant 2, we're still in positives. So we're adding 1 plus the square root of 3. So we still have the 1.866, 1.707, and 1.5. Okay? What about pi?
Negative 0.5.
Plus, it's 1. It's
So
0
sinus
plus
pi was 0.
That would equal 1 in my. Yeah.
Oh, I'm on the next one.
And then we add 1, we're at 1. I know, I looked at the wrong one for a moment. Okay, now, stop and think. What was the sign of 7 pi over 6? It was negative 0.5. So what's 1 plus negative 0.5? 0.5. Okay. 5 pi over 4. Well, that was going to be negative 0.7. So what's 1 plus negative 0.707?
0.3.
Okay. I have written down 0.293. I agree with what you guys are saying. Okay. And then this next one, we're going to be doing 1 minus the 0.866. So 0.134. Sine of 3 pi over 2 is... No. Sine of 3 pi over 2 is negative 1. And so when you add 1, you're at 0. Maybe that's what you were saying. Now, can I repeat here? 5 pi over 3 is going to be the same as 4 pi over 3 because we're in another negative quadrant, right? So 0.134, 0.293, 0.5, and 2 pi is going to be the same as what we had at 0, which was 1.
I think you have your. Never mind.
Huh?
You got like a minute to graph this.
We got a minute to graph it. Well,
Nice.
I'm not that stupid. It's not happening.
We can make it.
Now, here's what I'm going to say. You can work on graphing it. I'm trying to remember what this one does, and I can't even see. I think it's not exactly a circle this time. Okay, it's a slight variation of a circle.
That one wasn't
Now,
exactly a circle.
Here are my thoughts. Okay. I originally had planned that we wouldn't start the notes till today. So we would be starting the notes today, finishing them tomorrow. We only have lesson 6.6 that I want to do after this. And then we're preparing for chapter 6 tests, which I have scheduled next Friday.
Is that
So,
wishful thinking?
now, with that in mind, we could graph this tomorrow and I could give you a work day tomorrow.
That sounds good.
I'm good with that. I am loving that idea.
I mean, I could twist your arm if you want me to.
No.
Yeah.
Okay, now, okay, there are 6 graphs there. Numbers 1 and 2. 36, 37, 39, and 40. Okay? I can't, it's taken us a period and a half to do 4 graphs. So
that is kind of scary.
you can have the graph paper if you want it, but I want to make sure you have something to do during class tomorrow. However, I can't guarantee you can get all 6 done during class tomorrow.
Yeah.
So if you want to take the graph paper and get started, you can, but don't finish it. Leave some for tomorrow. Okay?
Trust me, I'm not gonna finish this.